Hi guys, welcome back to my channel, and today I'll be teaching how to solve a 2x2 Rubik's Cube. Now, standard cubes like 3x3 have a center, but a 2x2 has just 8 corner pieces just floating around. And that's what makes it so interesting yet simple to understand. So let's begin with the tutorial. So I'll just scramble the cube. So now let me quickly introduce you to the 2x2 Rubik's Cube. So a 2x2 Rubik's Cube has 8 floating corners and no centers at all. And like 3x3, we'll be solving this also in terms of layers, bottom first and then the top layer. Now since this cube has no centers, so you can begin with any color of your choice and make that color as the bottom layer, and you align all the 4 pieces orientation and position wise, and then you would move on to the top layer to solve it. So now let's begin solving it. As of now, I would take white color as a reference and I will build the white face first in the bottom layer. But when we would move to advanced tutorials for 2x2s, ideally you should be taking colors which has like the most number of pieces aligned. For example, for here green. But as of now, I'll just take white as a reference and then we will start building this whole layer. Now locate a white corner piece in your cube. Let's say I take this one. That means I would take this piece as a reference and I would build this layer with white color as my bottom layer. So let's say we locate another piece with white, let's say this one. Now what does this piece and this piece has in common? So this has white, orange and blue, and this has white, orange and green. So this and this piece have orange in common. So I want to align this piece right next to here so that an orange continuous edge is formed along with the white face. So in that case, you could just rotate the top to bring it just above the position where you want to insert it. So if you want to insert it here, I would bring it here in the top layer. So now there is this algorithm which is known as sexy move, and what it would do is insert this piece from the top layer to the bottom layer right here. So now for this algorithm to work, the piece that needs to be inserted in the bottom layer should be on the top right side here facing towards you. It cannot be like this on the left side. It has to be on the right side for this to work. And now you would need to repeat this algorithm a couple of times until you can see that this piece is inserted right over here in orientation with this piece. So let's begin with the sexy move, which goes like R, U, R prime, U prime, and for once it is not done. So let's apply it again. 2 times, not done. And in 3 times we were able to insert this piece from top layer to the bottom layer. Now similarly for the rest of the 2 pieces, you would perform the sexy move again a number of times to bring them to their correct position and orientation. But a fun fact that you should know is the maximum number of times that you would need to apply the sexy move is 6. But now why 6? Because 6 is the magic reset number for a 2x2 Rubik's Cube. And there's like a whole math behind it telling that after 6 repetitions, the cube would restore itself to its original state, and which is why the 6 is the magic number and also the maximum number of times that you would need to apply this algorithm. So now let's look for another white piece to put it into the correct position, say this one. Now this one is on the bottom layer but not at the right position, so we could rotate this to directly bring this to the top layer. Now where do I want to place this piece? So this piece has white, green and red, and this piece has white, orange and green. So this piece and this piece have like green in common, so we want this piece right next to this one over here. So now let's bring it to the position. So we want this piece over here right next to this. But again, to apply the sexy move, we need to hold the cube like this, where the piece that needs to go to the bottom layer has to be on the right top right corner. So let's say we apply the sexy move. It goes like, and wow, in just 1 times we are able to bring this piece from the top layer to the bottom layer right next to this one. So now let's locate the 4th piece that needs to go over here, and alright, it is in the bottom layer itself. Now previously what we did was we could just rotate this to bring it to the top layer, but that would mess up with the already existing this piece at the bottom layer, so we cannot do that. So instead what we could do is we could apply the sexy move one more time and that would bring this piece from the bottom layer to the top layer. And now you can perform the sexy move again a number of times to bring this back to the bottom layer in correct orientation. So once, not right, twice, not right, and in 3 times we were able to insert this piece, and now we are done with the bottom layer. So now you can use the sexy move in most of the scenarios, but there are some cases where you could just use your intuition to put the pieces to your places, and that would cost you lesser number of moves comparatively. Let's look at this scenario where this piece needs to be inserted here, right over here, and the bottom layer's color is white, and here white is facing towards you. So first I'll apply the sexy move, and then we would count the number of times we need to apply that, and then I can just show you by intuition that this could be actually done in lesser number of moves. So if I apply the sexy move once, twice, thrice, 4 times, and in 5 times we were able to insert this piece from top layer to the bottom layer. But let's look at this intuitively. So what I want to do is put this piece over here, but I cannot just directly move this layer because it would mess the already existing piece. But instead what I could do is take this piece away, move this layer on the top, we bring the piece back and put this layer back down, and I think we should be done. So let's say I take this away and bring the layer up, I put this back and put the layer down, and in only 4 moves we were able to insert this piece from top layer to the bottom layer. So now let's begin solving the top layer. Now for the top layer we would want either 1 or 4 of the corner pieces to be at the right position. So if 4 of the corner pieces are at the right position, we are already there. But let's look here to see what we are facing. So this corner piece isn't at its right position because we want red and green, but this has red and blue. Even this one, because we want blue and red, but this has blue and orange. Even this one, we want orange and blue, but this one has like red and green. But this one is at its right position because we want orange and green, and this has like orange and green, and yellow would go on the top. So this is the scenario we were looking for, where only one of the corner piece is at its right position on the top layer. So in this case, where only one of the corner piece in the top layer is at its right position, we would apply a very simple algorithm, and it would keep this piece as constant, but it would rotate the other 3 pieces anti-clockwise. That means this piece would go here with orange and blue, this piece with blue and red would go here, and this piece with red and green would go here. And I think that's what we want, right? So let's begin with the algorithm. The algorithm goes like U R U prime L prime U R prime U prime L, and we can see this remained over here, but the other 3 pieces are onto the correct position. And I think this algorithm is pretty easy to remember. Now let's say you face a scenario like this where this piece with orange and green is at its right position, but the rest 3 aren't. So this with red and blue needs to go over here, this one with blue and orange needs to go over here, and this one with red and green needs to go over here. So keeping this piece as constant, I want the other 3 pieces to rotate clockwise, and that's why we would apply the exact opposite moves of what we applied previously. So in this case I would hold the cube like this, and we want this as constant, so we would start from this side and not this side. So the algorithm we applied, and the opposite of it goes like U prime L prime U L U prime L U R prime. And so this piece remained constant, but the other 3 pieces are now at its correct position on the top layer. Now let's say you face the scenario where 2 of the corner pieces are at its correct position, but the rest 2 aren't. So this one with orange and green is at its right position, and this one with red and green is at its right position, but these 2 aren't. And since I mentioned that I want only 1 or 4 of the corner pieces to be at its right position, so in this case one thing you could do is you could just rotate the top layer clockwise or anti-clockwise, and then you will see that only one of the pieces will be at its right position and then the rest three wouldn't. So here this piece with blue and red is at its right position, but the rest three aren't. And again you can continue with the same algorithm, the same move that we learned to solve this scenario. So the second thing that you could do instead of rotating the top layer is directly apply the algorithm that I taught you. But then you need to understand keeping what piece as constant and rotating in which direction would bring all four corner pieces to their correct position. So hear me out. These two pieces are at its right position and these two aren't. So I want the piece with red and blue to come over here and the piece with orange and blue to come over here. That means I want the piece with orange and blue to come after the piece having blue and red. That means, let's say if I keep this piece as constant and rotate these three pieces clockwise, that means this piece would come here, meaning that the piece with blue and orange would come after the piece with blue and red, and that's what we want. Although I realized that these two pieces would shift here, here and here, but relatively to each other they would be in the same sequence. And as an outcome, what we would have done is bring all four corner pieces relatively to their correct position, and then what we could do is adjust the top layer to bring that to their absolute correct position. So now let's apply the algorithm. I want to keep this piece as constant and rotate these three clockwise. So I would hold the cube like this and apply the algorithm. And then we could just adjust this by making an U prime, and you can see that all four pieces are at its correct position now. So now I get that the second solution I explained might be a little complex to understand. So instead you could just go for the first one where you would just rotate the top layer and apply the regular algorithm. But I believe once you get better at knowing keeping what piece is constant and rotating in which direction, I think you'll just get quicker at this. So now we have placed all four corner pieces to their correct positions on the top layer and now only left with their orientation. So for orientation, we'll be applying again the same sexy move, but instead of holding the cube like this, we would hold it upside down where the top layer comes to the bottom right here, and then we would start applying sexy move from the corner that needs to be oriented. So let's say I pick this one and I would apply sexy move a number of times until this corner is oriented in the right way. So if I just apply still not, thrice and 4 times, you can see that yellow now faces the bottom and it is correctly oriented. Now for the rest of the three pieces, we would apply the sexy move in the same way, but instead of rotating the cube like this and applying sexy move here, instead we would hold the cube as it is, rotate the bottom layer so that the piece that needs to be oriented comes in the lower right corner, and then we would apply the sexy move here again. So if I just do it 2 times, then it is correctly oriented. Now I'll rotate the bottom layer once more and apply the sexy move, and in 4 times it is correctly oriented. Now I'll just rotate it again for the last piece and we would apply it a number of times, and then we can see that we have solved the 2x2 Rubik's Cube. So here's the fun fact that the nerd inside me wants you to know. Now you must have noticed that when we were solving the top layer and applying the sexy move for the orientation of the corner pieces holding like this, and if I apply it the number of times, and after this piece was oriented, you would have noticed that the top layer was disoriented, was messed up, and only after I would orient the rest 3 corner pieces, it would come back to its original solved state of the white face. Now what's the math behind that? So when you turn only the bottom layer to bring a new corner into the bottom right slot, you are actually using a technique which is known as conjugate. So you are keeping the right and the up layers as your mixing chamber, and the rest of the cube is just temporarily displaced. And since it is physically impossible for only one corner to be twisted, the cube's physics forces the corners to balance out, and the number of sexy moves needed will always be in a multiple of 6. And now the net effect on the rest of the cube remains 0 once the 6 move threshold is reached. So I'll just quickly cover an additional scenario where these 4 corners of the top layer are at its correct position and these two need to be oriented correctly. Now for this top layer where yellow is the face we are making, for these two pieces to be oriented, yellow is facing on the side. So in this case, obviously you could apply the sexy move, but you could also apply the algorithm we discussed in my 3x3 tutorial of orienting and aligning the corners of the top layer. And the algorithm goes like, and using the same algorithm we were able to solve 2x2 orientation of the top layer as well. So that's it from my end, guys. I hope you were able to understand how to solve a 2x2 Rubik's Cube.